Why I think mocking has a bad reputation. So there's a lot I can say about this. It's not that I think that it has a bad reputation. Maybe it's a little bit misunderstood. Um, so I think the best way to to start here is to review what is mocking, right? So it's a technique of testing that allow us to define expectations over interactions between, for example, classes, right? So I have class A that needs to interact with class B, and instead of executing the code on class B, I can say that class A is expected to call this method with this input and receive this output, so class B is never actually executed, right? So this is a way, a real world example of this is like I have a repository which I don't want to touch the database, and I just mock that repository in a sense that I define that I will execute method like find by ID with this ID, and I return and I get a record out of it. So the repository, the concrete implementation or the production implementation will never touch, so it will never execute, so it will never touch a database. And it's a very useful technique, as we might understand, right? But what I hear about mocking is people try to avoid it like the plague, in a sense that, and they have, okay, some understandable reasons for that. I just think that it steers from some common pitfalls that I've been found in my experience, obviously. But let's try to analyze a few of these. So two arguments I see commonly being used is that mocking is too verbose and mocking gives low confidence on passing tests. I can agree with the first. It is too verbose. Every time we're going to declare, when we use mocking and we're going to declare expectation, we gotta do those declarations on every test method, right? So every time I'm gonna test something on a class, I need to define the expectations of the interaction that that class has. And that gets to a point, can get to a point where we have a lot of expectations declarations, and that can become a little bit cumbersome to write, and God forbid if we have to change anything, right? So we need, if you change anything on this on this declaration on the the interfaces that support all of these interaction definitions, we need to change all those markers, right? So what people tend to incline is to using other methods of testing, other methods of testing doubles. And one of the most prominent I see is using fakes, right? So they have these fake implementations that they use on their tests. So with the main goal being that the behavior is encapsulated, right? In a way that if something changes, I change that fake implementation, and that all is automatically used and updated on all the tests that reference that, right? That's like encapsulation one-on-one of things, no matter if it's test or like other types of code, but it's encapsulation, right? And one thing that I usually argument is that, well, that can also be done with mocking. I can encapsulate my mocks and do the same reference. So it's not something specific like mocking. You can do it that way. I don't think that's the case. But the low confidence argument is the one that I find most difficult to agree with, right? So what do they mean with low confidence? Is that people tend to not trust when a mocking passes, so you have a green test, right? Because maybe in the experience, and I'm extrapolating here, but maybe their experiences come with, but I have these mocking definitions that are being well, that pass because my code executes in accordance to that expectations, but the real implementation is doing things differently, right? So if that real implementation is never to be executed, then when we go into production, we will fail, right? We will have an error. We will have some screwed up logic that is not caught by by the mockings. And the thing is, it's not supposed to be, right? So when we define our expectations, we are defining interactions, right? We are defining expectations over interactions, not over the concrete implementation. Okay? So we have this kind of public API on classes, right? That have methods that define what their inputs and their outputs, and we only declare expectations on that. So that's the thing. If the concrete implementation still has a bug, it will not be caught by mocking. What it will be caught is on their unit tests, right? So if we have class A and class B, and we are testing class A in Unity, but class A has some expectations over the interactions with class B, it's not the responsibility of class A tests to test class B. It's a responsibility to test class A. So when we use mocking, we also have to assume that class B, in this case, has their own tests and that they are passing. So trying to not that it's 100% free of bugs, but at least we have tests that confirms that it works. So we don't have to retest it. And that's the thing that we try to also do with other types of test doubles, right? But the main responsibility is that one. So if we go in with this frame of mind that class A tests aren't supposed to secure that class B is working properly, we don't have this low confidence. Because as long as we are abiding by the declared interface of the class B, we should not have problems. Meaning that as long as the interface of class B does not change, then our expectations, the defined expectations, which needs to clearly abide by the interface, because we will have errors if something changes on the interface, right? Then everything should be okay. We should not have low confidence, right? Even when we go into these very loosely development where we don't define interface and we are mocking concrete implementations, the same rules apply, right? As long as the public APIs of that class being mocked does not change, the expectations should also don't also need to change, and thus they are still valid. They give us the same confidence. So with these, what I think is that, well, I don't see many developers defaulting to like doing some contract testing. Contract testing being like defining interfaces and testing using those interfaces as mocking, right? So this is some kind of contract test. I'm not testing the concrete implementation. I'm just testing that I am interacting in an expectable way. And they tend to like change things, and that's completely valid, okay? Especially early on in development, where we are not yet very clear or very sure of how we want this architecture to be done. So we are changing, and then what happens is when we're using mocks with all that verbosity, we need to change mocks, right? So we changed one thing, we also had to change tests, and if we're not very careful, then our mocks will be completely desynchronized with whatever the current implementation requires. And that happens because the mocking API will not execute the concrete class. It will just create this kind of, I will use the word fake, but this shadow object, like this in-memory structure of a class, and will not execute the real one. It might have some checks, and I see that it happens when you use interface, where it says, hey, we cannot do this because it's not defined, but it's supposed to return this type of object, for example, as a response, and it's not returning it, so they can catch that, right? But it won't actually check if the method exists or if the name is correct, because, well, if something is changed on concrete implementation, and we don't actually update the markings in that sense, then those method calls will still like we don't update those tests that use those markings, so we don't update that class A's production code. So in test, it all passes, but then we go into production, it fails because we missed these updates, right? And I think these low confidence steers much from that. That's why I highly recommend when using mocking, and I use it extensively, is to mock interfaces. No, don't mock concrete implementations, even though that the problems might be kind of the same, or the challenges might be the same. At least we have a more deep concern about changing interfaces than changing concrete implementations, right? Because we should all know that when we change an interface, everything, even our IDE, will scream at us that there are some implementations of that interface that also need updating, right? So they need to change. So mocking an interface, I find it more secure than mocking concrete implementations. In this sense that there are a lot of other safeguards that will kick in and will alert us, hey, you changed this method name, or you changed this input, or changed this output. So the implementations of this interface also need syncing. So we also need to change them. So we also need to change that code, and we change those specific tests. And also that will include, if the IDE is smart enough, will also include the mocks. Or if you use some of those internal like refactoring methods that exist on current IDEs, they will also go and find the mocks and change it all, and it should all be good. But the verbosity is a thing that exists. And like I said before, people tend to avoid that, or kind of fix that, or go around that problem by using other test doubles like fakes. Because now they don't define the fakes every time they have a test method. They just they just reference another like class or something that contains the fake implementation. And as long as, and again, it's then applies the same thing as an interface. As long as that thing does not change, tests continue to pass, right? But when we do a fake, we got to think in this perspective too. To be able to create a fake implementation, and creating a fake implementation implies that we have a production implementation. How do we keep both in sync in terms of methods API? We have to have an interface, right? So that interface always comes into play. And so I found in my experience that I can be very quick in doing mockings, and can be quicker to doing mocking than to implement fakes, because in mocking, since I don't actually need like the class to exist, or the interface to exist in an immediate time, I can be in that iterative development process of testing things out, testing the waters, testing if my methods make sense, I've exploited enough, all that good stuff of a well thought out architecture. And then I can actually kind of go and create a shell interface, so I can just then compose the architecture of the class and add the methods and cement all that, right? So instead of just going and, okay, so I need to test. Now I need to I want to do a dummy or a fake implementation. So I need to create this class, but this also needs a production class. So I need to continuously update these two classes. I can use them in tests too, and also have to update this interface. So I find it a little bit more cumbersome, right? But I kind of understand the arguments that many people state or use to stay away of mocking. I just think that there are other fundamental issues that makes us want to keep away from this kind of from that technique, right? So it might also be that the class in test has a lot of dependencies, and that might also be a sign that the architecture is subpar, right? So if you have if we open a class and we see like 5 or 6 dependencies, me personally, the first thing that comes to my mind is that, okay, this class might be doing too much or orchestrating too much. And more often than not, I find out that many of those dependencies are either not for that class specifically, so that class will instantiate another class and needs to pass those dependencies down. So I call them transient dependencies because that class does not use them, in the sense that they will not execute their code. It's there just so they can pass it on. Or there's some logical condition that just executes the code of or use some dependencies if some conditions are true or false. So there's these logical branches that makes the dependencies kind of, they are maybe going to be used, maybe not, depends on what happens when the code is running. So yeah, and in that case, maybe it's a sign that we should look into into the class architecture and trying to like organize it a little bit better, right? So in the sense that, okay, if you have like in 5 dependencies, 2 of them are probably not going to be used or being used depending on conditional branching, maybe try to extract that out. Maybe you have a factory or something like that. There's a lot of design architecture. We might talk about it in another episode that will allow us to, okay, so based on some vectors of information or conditions of execution, that I know that I'll be using A and not B, right? So I don't need to instantiate them both, but I need to have something that will decide for me which of them I will be using. So, and that then can get into a very interesting network of graph in terms of dependencies that gets to another time where we can talk about it. So that's basically it. So I think that we need to be very careful about. And I was almost forgetting something. Another thing that might make people stay away from mocking is when that a class, but we have this code we use frameworks nowadays, right? So it's a very same thing to do. And sometimes frameworks, especially in the types of languages I use, we usually have this service container that handles all these dependency instantiation, and sometimes they have utility functions that loads those dependencies. So I can call upon the service container inside a method or something like that, like in the middle of the code, to instantiate dependencies, right? So when that happens, and that prevents us from mocking, because what are we going to do? Are we going to mock the service container? How will that work? It's just insane, right? So that makes extremely hard for implementing mocking strategy when that happens. And what people tend to do is just, maybe I won't do this in unit, I will do this in an integration level or something like that, and I'll just use the service container, and I'll have a lot of things to instantiate to, and I'll have this framework loaded in memory, and then our test stays they are a lot slower to execute, right? So when we are very careful and have this, we are very careful about how we architecture our class, when we use proper dependency injection and dependency inversion, and all of those kind of are properly thought out and implemented, we don't have a hard time using mocking. The mocking does not give us low confidence, and it's actually a very sane thing to do to test things that are out of our control, right? So can you imagine having a concrete implementation of an outside API? It's just not possible, right? We're going to have a container running this service that sometimes is proprietary and we don't have access to? No. We go into the documentation, we know exactly what it's expecting as an input and what it gives out as an output and what we need to call. And we have no other way, right, then to mock those expectations, saying, I expect to call this URL with this body and get this other body in response, and so on and so forth, right? It's a very thing to do in terms of testing like APIs or the other things in the in the infrastructure level, right? But yeah, that's my thought about it, and I think that mocking still has a little bit of as challenges, definitely. The verbosity being the one that I can agree the most, but I just find it hard to agree with the low confidence. I don't think that's the case. It only happens if we just being careless about our architecture, and that's just the thing, and that's just what how things are, right? But once again, I think that if you are very careful about it, about architecture, about mocking only interfaces and not concrete implementations, we can go a long way in an iterative process. And when we find that we are repeating a lot of these mocking, a lot of these expectations, we can extract it out with like a utility class that we reference in our tests, and we don't exactly have a fake implementation, but we get the benefits of like a fake implementation. We have all these mocking, all these helpers that we can quickly reuse and re-reference. Yeah? And that's all I have to say about it. I hope you enjoy. Please feel free to challenge me, to help me, give me other arguments that might make me think other way. I'm always very receptive to that. If you go into the description of the podcast, you can see there's a Discord server. Join, come talk to me, come hang out, and until the next episode. Bye bye.